In this video, we're again going to cover a common coding pattern that we see, and it's very relevant to data science and when you're working on data type of applications, and that's the sliding window pattern. So we reviewed the sliding window pattern in the last video, and now we're going to see it applied again with a little more complicated problem. So this problem is we have a time series data set with hourly website traffic. So if we can just look at the example, and we have traffic volume. So it's basically how many people visited your site during that hour. So in the first hour or the 0th hour, there was 20 people. Next hour, 10 people, 50, 1, 30, 40, 25. And what we want to do is we want to return the index where there's the largest, highest average traffic volume within a 3-hour window. So just looking at this sample input we have here, um, well, we see 50 is a really big number. We see these numbers are pretty high. We see these numbers are pretty high. So intuitively, I mean, it has to either be this window or this window, right? Well, if we look at 3-hour time windows, 20, 10, and 50, that's an average of 26 and some change. But here, 30, 40, 20, that's an average of 30. And so the 30 starts at index 5. The ith element is, the fifth element is 5, starting from 0 base. So that's what we want to output. So let's jump right in and see how we can use the sliding window technique to solve this problem. So the first thing that we want to do is we want to have some initial window set up. So let's see, we have our window sum. So we want to get averages, right? So how do we get an average? We just sum the data and divide it by the length. So our window sum is the first 3 elements, and then our maximum average, we can just set it to be the first 3 elements to start, and then as we slide the window across, whatever the next maximum average is, that's what, I mean, that's the index we're going to return. So our max hour is at the 0th index, right? So this is just the initial window setup. So this is saying, let's start with the first 3. Let's call that the maximum. And then as we slide the window over, we can update as we need to. So currently we're saying the maximum starts at index 0, and it's these 3 elements, 20, 10, and 50. So now we just want to slide the window across the data. All right, so for I in range of 3 over the list that we have of traffic data, we can take the window sum, and this is where we apply the sliding window technique where we don't want to recompute things that are already computed. So we take the window sum, we subtract the last value that's in our previous window that we calculated, and then we add the next piece of data. And then our window average for this is going to be equal to this window sum divided by 3. Okay, so now we have our next window. Sorry, this is window sum. So now we have our next window average. So originally started with 20, 10, and 50. Now we're looking at 10, 50, and 1. And so we just need to check, is that bigger than the average of our currently best or highest window? So we want to update the max average and max hour if a higher average is found. So how do we do that? So if the window average, this is our current window average, is greater than our maximum average found so far, then the maximum average is going to be equal to the window average. We're just updating the max to be the current window. And then we also want the index where that happens at because that's what we're going to return. And that's going to be at index I minus 2, right? Because if we're looking at this window, our I value is at the rightmost side of the window, so we want to go 2 back to get the index at the beginning of the window. So that should update it. We'll just slide over for the whole list, and then we'll return the max hour. So it should be as simple as that. Let's run to make sure everything works. And it does. And that's how we can use the sliding window technique to look at average, find the highest peak volume in either application traffic or website traffic. And you'll see this a lot in data science and data analytics, that this is something that you need to compute. So what's the runtime of this? The runtime of this is big O of n, where n is the length of the traffic volume input. And again, this one looks small, right? Because the window size is only 3. But you can imagine this window size being larger, and the larger the window size, the more efficient using a sliding window technique is going to be versus doing some brute force solution where you're repeating the window sum every time you slide the window.